today we're looking at the trapezoidal rule for calculating area. So we've looked at this already before, so it's just a quick recap on it. So the area approximation, this formula is in my log table, so it's basically h over 2, so it's basically the length of the intervals over 2, or the width of the intervals over 2, y1, so the first term, the last term, plus 2 times all the terms in the middle. Okay, so here I have an example. Using the measurements provided, find the area of this shape given h is equal to 1 unit. Okay, alright, so I have basically here my y starts at 0, my y1 is 0, my y2 is 3, my y3 is 3.62, my y4 is 2.86, my y5 is 3, my y6 is 3.58, and my y7 is 2.66. So then I'm using my formula. Okay, so my area, this is my formula that I get from my log tables. I was told that my interval, my h is equal to 1, so I go 1 over 2 bracket, right, my first term was 0 plus my last term is 2.66 plus 2 times everything in between, so 2 times 3 plus 3.62 plus 2.86 plus 3 plus 3.58. okay, and when I work all of that out I get 17,390 square units. Here I have another example. So it says the circle shown has equations x squared plus y squared is equal to 25. Okay, so this obviously has a circle at 0, 0 because it's x squared plus y squared and my radius is 5. So I'm asked to find y in terms of x. I'm asked then hence complete this table, and then I'm asked use the table to estimate the area of the quarter circle using the intervals h is equal to 1 unit, and then I'm asked complete the table using h is equal to 0.5. And the final thing that I'm asked to do is compare both answers with the answer obtained from the area of a disc formula, correct to 3 decimal places, and what conclusion can be drawn. Okay, so the first thing I need to do is I was asked to put y in terms of x. So I have x squared plus y squared is equal to 25. So I have y squared is equal to 25 minus x squared. Y on its own then is equal to the square root of 25 minus x squared. Right, then I'm asked to fill in the table from x is equal to 0 to 5. So when x is equal to 0, I find out that y is equal to 5. When x is equal to 1, I sub it in and I find out that y is equal to root 24. When x is equal to 2, I sub in and I find out that y is equal to root 21. And when x is equal to 3, I sub in and I get that y is equal to 4. And the final one, when x is equal to 4, I sub in again and I get y is equal to 3, and x is equal to 5, I sub in again and I get y is equal to 0. So this is what my table should look like. Okay, so here I have x is 0, 1, 2, 3, 4, 5. My y then is all the answers that I've just found. Finding the area then, I get the area, so I get a half, right, so my first term is 5, plus my last term is 0, plus 2 times all the terms in between, so root 21 plus root 24 plus root 21 plus 4 plus 3, and I get my area is approximately 18.982 square units. Right, I have to do the exact same thing, okay, but this time I'm using my interval that it's 0.5, okay, so that h is 0.5, so going up in 0.5 every single time. I do the exact same thing as what I was doing up here, so I'm subbing in to find my y value. So for the first one, I go that x is 0, I find out that y is 5. When x is 0.5, okay, so I sub in and I get 4.975. When x is 1, okay, I get 4.899. When x is 1.5 and so on. So I'm just subbing into the same formula that I was using up here, and that's the table completed. The area then is I get 0.5 over 2 because that is my interval. Okay, so how wide my interval is, and it's going up in 0.5, so over 2. 5 plus 0 plus 2 times all my scores in between, and I get that my area is equal to 19.404 square units. Then I was asked to get the area using my area of a sector formula, so it's the area of a quarter of a disc. Okay, so it's quarter pi r squared, so it's a quarter pi, my radius is 5 to be squared, and I get 19.635 square units. So what I can say, what I'm noticing, as h gets smaller, the answer approximates more closely to the disc formula answer. We also note that both the approximations are smaller than the true answer, as would be expected from the shape of the graph. Okay, so that's just what happens as we have more intervals, it gets more accurate than based on fewer intervals. Okay, so here I have an example. A farmer wants to find the area of one of his fields which is shaped as shown. Okay, so I'm going to submit the book I got these from as well. He uses a map which has a scale of 100:1. He divides the map of the field into two using a horizontal line and then draws perpendicular offsets at 10mm intervals. Okay, so then by measuring the length of the offsets, use the trapezoidal rule to estimate the area of A plus B, given your answer in hectares, correct to 2 decimal places. So then 1 hectare is equal to 1,000 meters squared. Okay, so the solution, okay, so I'm using my trapezoidal rule. Okay, so I have h over 2, my first term, my last term. Okay, right, I was told that my intervals, okay, is going in 10mm, so it's 10 over 2 bracket. Okay, so it's my first one, which is 0, plus my last one, which is 20, plus 2 times all the intervals in between. So I have 2 times 23 plus 28 plus 22 plus 23 plus 28, and I get my answer is 1,340mm to be squared. So I'm told, okay, that my ratio here, okay, so 1,000mm is to 1mm, basically is what it's saying. So then I have 1,000 by 1,000mm squared by 1 by 1mm squared. So that's 1 by 10 to the power 6mm squared is to 1mm squared. So the area of the true then is 1,340 by 10 to the power 6mm squared, gives me 1,340 meters squared, because 1 meter is equal to 1,000 to be squared millimeters squared. So I actually get my answer is 0.134 hectares. Okay, so in this particular example, I'm told if h is equal to 1 centimeter and the length of the offsets are as shown, find the area of this map. Okay, so if the area of the map is 17.23 centimeters squared, find the percentage error in using the trapezoidal rule and h is equal to 1 centimeter. So by taking new measurements with h is equal to half, find the second estimate of the area. Right, so this is what the diagram looks like. Okay, so then I'm going on now here to use my trapezoidal rule. So it's h over 2 bracket the first term plus the last term plus twice everything in the middle. So my interval in this case, okay, so the unit width is 1 over 2, and it's my first term is 0, my last term is 3.66 plus 2 times everything in the middle, and I get my answer is 17.61 centimeters squared. My percentage error is equal to 17.61, take away the true value, all over the true value multiplied by 100, and that's equal to 2.26%. And then an area of a quarter of this then gives me a quarter of 0 plus 3.66 plus 2 times all my intervals in the middle, and I get that's equal to 17.505 centimeters squared. Okay, so for this particular question, I have y is equal to 3x minus bracket 0.5x to be squared. Okay, so this is what the diagram looks like. I will give the solutions to you also from the book that I was using. So using the trapezoidal rule and an interval value of h is equal to 1 centimeter and h is equal to 0.5 centimeters, estimate the area under the curve. Okay, so I'm trying to find out the area underneath this. So I get y is equal to 3x minus 0.5x squared. So my solution then, okay, so it's h over 2, I'm using the trapezoidal rule formula. So I have my interval, it's going up, okay, the gap between my width is 1, so it's 1 over 2 bracket, my first term is 0, my last term is 0, plus twice everything in the middle, and I get that my answer is equal to 17.5 square units. And then area of the next part asks when h is actually equal to 0.5, estimate the area under the curve. Okay, so when h is equal to 0.5, so half over 2 will give me a quarter, first term plus last term plus twice all the values in the middle, and I get my answer is equal to 17.75 square units. And that's all for today.